Hello everyone, I am Ayush Mishra and this is my channel RustTuber. You must have heard about Bitcoin. It is the most known word in the space of cryptocurrency, and blockchain is the key technology behind Bitcoin. As the name indicates, a blockchain is just a chain of blocks. In this video, I'll be showing how to create custom blockchain application in Rust. I am assuming you are aware with Rust programming language. So before we get started, let's take a look what is blockchain and what is block actually looks like and what are the hashes. This concept was introduced in 2008 by Satoshi Nakamoto as a part of the protocol behind the digital currency Bitcoin. In blockchain, each transaction is recorded in a block. Each block has a special timestamp and link it to a previous block. Each block is identified by a digital signature, which is a mathematical technique used to authenticate block. So let's see what a block actually looks like. So block contains the following things: a timestamp, its own hash, is the previous hash of the previous block, and the transition data. So basically, timestamp is just to indicate when the block was created. Hash is basically a digital signature which is created using transition data and hash of the previous block. The previous hash, it's a basically hash of previous block. If the previous block data is changed, then the previous block hash will also change. The transaction data depends upon the type of blockchain. So, for example, Bitcoin blockchain contains information about the sender, receiver, and the number of bitcoins to be transferred. The first block in the chain is called the Genesis block. Each new block in the chain is basically linked to the previous block. So, why don't we create a blockchain application in Rust? Let me show you the terminal. So, let's create a new Rust project. We can name it as a Rust chain. Let's import this in ID and let's start coding. So here it is a Russian project which has a default cargo HTML file and the main.rss. Let's start with creating the block. We don't need it now. So let's create a block. As I mentioned, we need a timestamp, a hash, hash of previous block, and transition data. So basically transition would be a vector of transition. Now we would need to create a transition. Let's create a transition. For this demo, we can let's assume we have a sender, a receiver, and amount. So now we have a block and we have transition. Okay, sorry, so we have to import this. Let's create a library file where import it for so we can access globally. Public transaction. And then we can import it here in block.rs. Okay, so okay, let's create a block constructor where we'll be creating block from the previous block hash and the transition data. So implement block. Let's create a new function. Let's transition would be a after of transition. So this function will return block itself. So now we need a timestamp. So for the timestamp, let's create a function in library.rs to generate a current timestamp. So we need a dependency. Let's add a dependency of time. Yep, this one. Refresh my dependency. Import it here. Add a function for library. So I added a function now which will generate timestamp in millisecond using the time crate. Here it is. Let's go back to the block constructor. Block. First add a timestamp. We need a function to calculate hash. Where we will pass these three variables: previous hash, transaction data, and time. Okay, so my block is ready. Now let's create this calculate hash function in the library file. So before creating this calculate hash function, I would like to tell you that as I mentioned above, each block has its own hash. So this hash is a digital signature which is basically unique to each block and used to validate authenticity and integrity of block content. So there are many cryptographic algorithms are available, but we'll be using SHA-256 for our application. Let's add a crate to what the generating hash. We'll be using crypto hash crate. Let's go back to library file and add a function calculate hash. it this function will have three parameter: previous hash, transaction data, and timestamp. This function should return hash and a string. Let's create mutable vector bytes. Okay, so we need to refresh it so that dependency can be downloaded. It is downloaded now. Crypto hash and its hex digest method. We'll be using, as I mentioned, we'll be using SHA-256 algorithm. Here it is. Now let's add block content in bytes. Sorry, this is bytes dot extend. You have to convert in U8 BG method. Okay, now we need to a method to convert transaction into the U8 bytes. Let's go to transaction and add a constructor here. So not a constructor, add a method. dot extend at sender. Then we have to convert into U8. Okay, here it is. Go back to library. Add transition bytes. Oh, let's rename it to transactions. We have to collect it as a vector of U8. Okay, so what is the mistake I have here? This is the transitions and the vector of transitions, and then um, so yeah, so let's add rehash in the bytes. Okay, so now we have a calculator function ready. What is the next step? So my block is ready. My transaction is also ready, and the calculate function is also ready. So now let's try to add this block in blockchain. Let me compile it if I have to see if I have made any mistake. Oops. Okay, here it is. So now let's create a blockchain file. Create blockchain struct. So blockchain will have all the blocks. So create a block, vector of block. So create a constructor to generate this blockchain. You also need a function to add block in this blockchain. Let me rename it to add it as a blocks instead of block. So this method will add keep adding block in the blocks of the blockchain. Okay, so my blockchain is ready. Now what is the next step? Just add the block in the blockchain. In the main.rs. So before adding the block in the blockchain, let's do some refactoring. In the library file we need to add blockchain. We'll be renaming our library as Rust chain lib. Put let's add a mutable blockchain. So first we have to create a genesis block. It would be the first block in the chain. So in the first block, the previous hash should be 0, as it has no previous block. And a vector of transactions let's say sender is Ryan. And receiver is Dan. Okay, so now we have this Genesis block. Let's add this Genesis block in the blockchain and print it. It's just provide the facility to print struct in a pretty good format. Let's run the program. Oh, okay, now we need the same for block. To add the debug trait. Uh, okay, so here it is my first blockchain. We now we have got success to add a Genesis block in the blockchain. Let's try to add few more blocks and then we'll run this program again. So let's go back to our main.rs. So in the first now since we have already created Genesis block, so in the next block uh, we'll be using Genesis block hash as a pre-hash. And then this corresponding transaction data. Let's see. Sam is sending data to Michael. And the amount is 2500. Let's create one more block. And we'll be using first block's hash. Now let's say this time Michael send data to Dan, and the amount is 1000. So we have added both blocks in the blockchain. Now we put in the forward clippy. Okay, so we have got a lot of warnings. We can remove them. Oh. So let's run this program. Yeah, as you can see, we have got a blockchain with 3 blocks. So this is the first one in the Genesis block, where we have 0 as a pre-hash, and this is the hash of Genesis block. Now if we see the first block, we can see the previous hash and the hash of Genesis block is same. And if we go to the second block, we can see the previous hash of the in the second block is equal to the hash of the first block. So here it is, like now we have created our first blockchain application. So you can find like the code uh, in the block link. uh, so we have got a working chain of block, but we have not covered validation, mining, proof of work concept of blockchain, so we'll be covering them in the next video. Okay, then thank you everyone for watching this video. I really enjoyed. Thank you.